Halo, halo teman-teman. Hello friends. Welcome again. Sorry, because last time I've made my stream quite a few days ago, like a week. So, like a week ago, I just made my last stream and been not streaming since then. So it's already a couple of days. But yeah, because of uh, my working task, which is quite it's just another excuse that I'm busy. Yeah, because I'm actually working for other project also in my company. So pretty much quite busy and almost a bit difficult to find time to for me to actually start streaming again. So yeah, I know it's another excuse, but please bear with me. So we're going to continue again programming or discussing about few things, maybe architecture, maybe IT discussion while I'm programming. The way when I'm thinking about anything, I will just spew it over on the channel. So anyone who willing to ask or please join, ask away about anything. If I can answer, I will answer. If I cannot, maybe I just get confused a little bit looking to Google, and then if I can answer, I will answer. It's a little bit different today because I tried to learn how to do programming with Vim. So usually I do programming using GOLANG. I've been subscribing to GOLANG, GOLANG product. I've been subscribed to them for years already, but I've started to feel that using GOLANG or in JetBrains product is too easy, meaning that it gives me lots of productivity and it helped me a lot with lots of things. Coding with IDE from JetBrains is really make things easy for me. At least that is what I know. So I'm getting too dependent to the IDE, which is good or maybe it's bad. I don't know. But now I'm trying to learn Vim. So I start to use Vim with VimGo plugin, and there is a Control P plugin. I don't know if you code using Vim for Go and then you are doing this day to day, maybe you can help me. Maybe you can teach me to give some kind of advice or tricks on how to code GOLANG in Vim. So please bear with me. I will be confused because this is just new to me. If you see me puzzled to do some kind of task using Vim, please bear with me because I just learning. And if you want to learn with me, then yeah, let's go. I am assumed that this is going to be hilarious, so no problem. Yeah, let us start from our last session. Yeah, there you go, our Vim. Yeah. I have some notes previously made using Sublime, I think. So, yeah. Anything, guys, if you have any questions about GOLANG programming, if you see something and you want to ask, maybe not always see, maybe in your project you do something and then you have question on how to do things in GOLANG, just ask away. If I can answer, then I will answer. If I cannot, then maybe let's confuse together. Let's look together the solution on the internet and how to do it. Let's test something. If you want to do some testing, maybe some proof of concept, then let's code together. Any question? Yeah, from our last session, we are working on this project called Simon. You can see in the description about Simon project. There is a source code that you can open from my repository. Just simply fork away and then you can pull. Oh yeah, by the way, guys, I'll try to talk most of the time using English, but I'm an Indonesian, so English is actually my second language. My mother tongue is Indonesian. So if you want to ask in Indonesian, Bahasa Indonesia, I will gladly answer in Bahasa Indonesia as well. But if you have no problem with English, well, my English obviously is not that good, but I will try to answer in English unless otherwise you ask specifically if you want to talk in Bahasa. So, okay, let's continue. Yeah. If you don't know what I'm doing right now in terms of programming, what project that I'm currently do, this project is called Simon. It's a synthetic monitoring tools, pretty much like uptime robot, but this is our own uptime robot, which is actually what we're going to do is something is more advanced compared to uptime robot, where we can monitor for server. If you don't know what uptime robot is a service provided by Uptime Robot. You can search in the internet about Uptime Robot. It's a service where you can subscribe a service to them, and then you can create your account there, and then you ask Uptime Robot to monitor your server, which is your online server. Maybe you are an administrator and then you want to make sure that your website is up and running. If in a certain in a way that you want to make sure that the server is not down, because obviously often your server is very important that it should not be down because of error or because of any network congestion or whatever. So you want to monitor your server, you go to Uptime Robot, you create your account there, and then you register your the server URL, and then make Uptime Robot to check your server every 5 seconds, 15 seconds. And then in the end, after a day, after a week, after a month, you can see the performance, the what we call the ping of the server. You can see how much is the response time. Sometimes it's go 50 milliseconds for the URL to respond. Sometimes it go 150 milliseconds. Sometimes it's go to 5 seconds. I don't know. And then you can see the graphic, how good is your server performing in the 24 hours pattern, maybe in a week. What day is actually your server is performed the best, or what hours your server is actually going a rough time, meaning that the performance is a bit low. Maybe it's getting very, very busy. So you'll know that the server, how to actually to see your server performance. So we are actually going to do that. We are creating something like Uptime Robot, but the idea is that the application that I'm creating here is a very simple agent. The idea is that this agent will be distributed across many servers located in Indonesia, located in Singapore, located in many different parts of the world, and then you can configure this application that I'm creating to monitor a certain URL, so you know how it performs when it gets called from Singapore, getting called from Germany or whatever. So you know, based on your user base, how is your services performing. Because often you have customers from around the world, and then you want to focus that this customer should be served by your server best. So you know. So when you have a service that you target that this service should be called by Indonesian audience, performance should be good, then you must make sure that whoever call from Indonesia have the best performance when they call your service. This is become common because when you deploy your solution in AWS, which is a server located actually in America, but your user base is mostly on Indonesia, so you want to make sure that the performance of your server, which is live on AWS, when you call it from Indonesia, the performance is always good. Yeah. So yeah, that's it. Yeah, what we are going to do is actually we code for an application that we're going to deploy around the world, and then this application will receive order from a server to do some kind of HTTP call. Maybe it's a post, maybe it's a GET, I don't know. And then we try to get metrics from that call. So yeah, without further ado, if you want to know the detail about what I'm doing here, you can go maybe 5 episodes before, 5-6 episodes, and then you can watch what is the idea, and you can see how I do coding on these applications. Yeah, go back to our design, not our design, our plan. So the agent will receive, not will receive, it have an internal database, which is a key value database, where it is what I call it as context. So an agent have a context. Within the context, the context is actually a map of string to string, where the key is obviously is a string, is a map string to string. The second string, the value is actually an expression. So for example, if we have some kind of this, like task name, and then you have an array like, so it is actually an array. So this key actually referring to an array. This key also referring to an array. This key is referring to an integer. This one also referring to string. This thing is referring to a string. This is referring to another string. Sometimes an integer. You can see sometimes it contain an expression. So not a string, not an integer, but this is an expression. So yeah, actually all of this is an expression. The value is always expression. Expression could be a constant like this one. This is an integer constant. This is a string constant. This is an expression where you have a string concatenated with a written value of a function. The function can have argument and so on and so forth. So the value part is an expression. So if you go like 3 episodes before, I show you how to create a DSL, domain specific language, to evaluate this expression, and it is done. So we have to refine how our engine actually go forward from now. Okay, you can imagine that the idea is if we have such agent, the agent must be able to execute multiple HTTP call or execute multiple monitoring tasks. Because obviously an agent should be able to do task for different client. If we have Google as our client, mean that from any particular agent, we must be able to monitor Google's target server. And at the same time, if we have, I don't know, the TICOM's server, meaning on the same agent, we must be able to monitor Google and the TICOMs. So from one server, from one agent, we must be able to distinguish that this task is belong to which monitor. So so task name consists of the name of monitor that need to be done. So actually, for example, task name login could be login owned by, I don't know, the TICOM or owned by any other server. Let's put into context, because otherwise when I'm explaining this, we're going to get confused. assuming that our agent is running monitor, which is the client is, let's say something familiar, like Gojek, Tokopedia, or what is familiar for us? Gojek, Tokopedia, Grab. Okay. And then Grab have a couple of tasks that need to be monitored. Maybe Gojek have GoFood project, and they also have GoSend project. They have lots of other Gojek sub-services. The same with Grab. Grab also have lots of other services. Maybe the Tick also have the same. So we have monitor, what we call is, for example, in our context is like Gojek. Let's have a task, for example. Task name is Gojek not Gojek, GoFood dashboard. And then maybe there is a task called Grab order, something like that. And then this, I know it's a little confusing. Let's call it probes. Okay, we have multiple probes. And in each of these probes, we'll have tasks. For example, namings now is getting confused. I'm even more confused now. Probe names, and then we can say probe dot GoFood dashboard dot tasks. The task is login and dashboard. It is logical because if you want to do, when you want to monitor some other server's dashboard, you cannot access the dashboard if you cannot log in. So you have to log in first, and then after you log in, you will call the dashboard. Then you measure do your measurement. So we can say that when you want to monitor GoFood's dashboard performance, you need to have two tasks. First, the login, and then you call the dashboard. This need to be done in sequence. And then we can say that this probe dot GoFood dashboard have a schedule. Schedule means that you monitor this GoFood dashboard activity every 5 or 15 seconds from now, or every 1 hour starting from tomorrow, or whatever. So we need to specify on what time that this monitoring will be executed. So based on the requirement that I get, we're going to have list of timestamp. Could be hundreds, could be thousands of timestamps that we need to execute this task precisely. So we have a timestamp. I don't know, something like that. Timestamps means that it will be in the second, unique timestamp second in UTC. So you have to put that this value is a number of seconds since 1970 in UTC, not in our local time zone. So it will be in the UTC. So we have multiple second. Maybe this is, I don't know, and many more. So for example, this is the blah 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 7/4 second, blah 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 7/5 second. Oh, 4, 7, right? So stupid. 7, 5, 7, 6. So it means that this is going to be called every second, like that. This is just for illustration purpose. And then from this probe, then we can specify the login. So we're going to use something like this. login, like that. Type is HTTP. It should be an expression of string, and from there we obviously can put something like URL. So when we call that, it should be something like gofood.com/API-login, or something like API v1 API login. And we know that we're going to use a method. The method will be post, and then we're going to put even more header, content type, application/JSON, and we need to provide a body. Body, we put a JSON, like, yeah, it's a string, right? Because the body should be a string. Username, some user, and then we have password. Secret. So we assume that we're going to send this inside the body in our request. Okay. After you logged in successful, okay, in order to continue after the login, because this is after the login, we can see that there is a dashboard task. So we can put something like dashboard. Okay. Type is HTTP call, and then dashboard URL is maybe API.dashboard, and then it's a get because you want to see, okay, using a get, and then content type. We don't need content type because we only fetching informations, but we need to have authorization header for the request. Oh, we need to put some request, right? So login, yeah, I missed that, something like that. Okay. Here, authorization should comes to a bearer concatenated with a return function of let's copy from here because I already created this function, JSON path. The first argument is the response body of the first request, of the login request. And we go to the JSON path, maybe data dot access. So this is the idea. We're going to send this to our agent, and then our agent immediately understand that, yeah, it have two tasks, which is the GoFood dashboard and grab order. For GoFood dashboard, it will look something like that. It will know that how many tasks for each of the probes, and then each of the probes, they know what is the execution time, the schedule, and for each of the requests, they will know yeah, this probe have login. This is the task login. For the request type is HTTP, because why we need to do this? Because we plan in the future that the task, the login could be not an HTTP. It could be an, I don't know, it could be an FTP, it could be a ICMP ping, maybe it could be a socket operations, anything. So for now, our implementation is only HTTP. So we put type is HTTP, and then by knowing that the type, so there is not request login type. Okay, so by knowing that login type is HTTP means there is a login request, and there will be a response will be put into the context. Yeah. Again, what I'm telling you here maybe is not clear for you what I'm talking about here, but if you have any question, just simply ask away in the chat. So yeah, we have probe, we have multiple probe, we have each of the probe have multiple tasks. Yeah, because there is a grab order here, we're going to create the same here for a grab order. So it could be something like this. We repeat all over again, but this time is for grab order. Yeah, all of those. We assume that this grab order of course with the schedule also. Let's not forget that. Yeah. Yeah, something like that. So for the GoFood probe, we know how many tasks, what is the task, what is the schedule, also for the grab order. Okay. Okay, so let's adjust. I don't need to save this. Okay, let's adjust our logic here to have the probes to have multiple probes, where each of the probes will have tasks. So let's do something like that. So okay, let's create a new GOLANG. Okay, so we have a Simon agent package. Type probe. Probe is a structure. It will contain task, but a probe should have information like probe name, and it should have schedules, which is an array of integer 64, because this is a timestamp, number of seconds since 1970. Then there is a task. Yeah, we actually have let's split this. How can I split? Escape, Control V. Oh, V is VisualBox. Oh, sorry. Control W, split, good, and then Control W, which, okay, Control W, and then Control P. I want to open my job, right? Yeah, job. So we actually have a job here that will do the execution of a task. So we're going to change this. Okay, let's do this because we are running in Vim, so please bear with me. Okay, let's switch. Oh, not Control WW. We have a task. Type task. Okay, a task would contain. Oh. We are actually duplicating what is already been done with a job here. We're going to copy the job as task. Control, not Control V. Okay, copy that. Right, and then Control W, like that. P, no? How can I easily copy from one text to the other text using Vim? Remove that. Okay, close it. How can I copy this in here? Okay, escape, Control W, no, Control W, then we copy this, V, like that. How can I copy? Oh. How can I do copy? Let's look into our Vim cheat sheet. If you know how to do it, please help me. So, okay, working with, okay, visual mode. Okay, you have a mark text. And then how to copy and paste. YY is okay, yank, P, put, D mean delete, delete. Copy the character from the word, from the cursor position to the start of the next word. How copy and paste actually work in Vim? This is I really clueless. Vim, copy, paste. Okay.
Copying and pasting between files in Vim is kind of a pain until you learn how to do it. So here's a quick demo. The first thing that we're going to do is use Vim to open up two files. So we can open up a single file just by typing Vim, then a space, then our file name. But if you want to open up multiple files, we just do another space, and then the second file name. And if need be, the third file name, and so on. In this case, we're just going to open up two files. So our first file
This is
is
copy and
text1.txt.
paste of files.
And you can see that in the top left corner, most likely. And so in this case, all I'm going to do is just get into insert mode.
Maybe this one is more
Hey guys, Brendan Productions here, and welcome to the next part of how to code or how to use the Vim text editor. There's a lot to cover today, so I'm just going to jump right into it. And just go ahead and open up gvim, graph command line :e, which means edit, and then the file name. So we're just going to edit test.txt. And then once we do that, it automatically opens the file, and it did it rather quickly as well, and we can get right to editing. So the next thing I want to discuss is the copy, cut, and paste functionality. Now, the copy, cut, and paste functionality actually works a little differently than everything else does within your computer. In fact, when using Vim, it has its own specific buffer, which means if you want to copy, cut, and paste using the key commands that I'm about to describe, well then you're only going to copy, cut, and paste into and out of Vim. You're not going to actually be able to use these keyboard commands to take anything out of Vim and then copy it or paste it somewhere else. You're only going to be limited to whatever you are working on in Vim, in Vim's current buffers, is what they call it. So let's go ahead and get started. The first thing I want to talk about is the copy command. Now in Vim, it's not actually called copying, it's called yanking. And what you need to do is you can yank things. You can just yank things. So since it's called yank, you do this with the keyboard command Y. So if we were to go over to this capital T here, using our basic navigation techniques that we've learned, and press Y, you can see that it actually brings up the little half cursor, which means it's waiting for a modifier. So if we press Y and then L, we know that what that does, using our knowledge from the last tutorial, is it actually opens up the yank command, and then it does it one time. Like, since we combine it with a modifier of L to move to the right, it yanks from the current position to one position over. So it will copy our capital T. Now, while still in command mode, we can actually move down a line and press P to paste. So if we press lowercase p here, we're just going to go ahead and paste this capital T right into our document. Now, just like with all commands, we can also use capital Y to yank to the end of a line. So I just pressed capital Y here, and then if we go onto this line and we press P, you can see that it actually yanked the entire line. So that's interesting. So apparently capital Y yanks the entire line. So we've already covered yanking, and keep in mind that yanking can actually be used with all modifiers. So for example, if we want to yank this word here, another, we can type YE, and then that will yank from our current position to the end of the word. And then if we type P to paste that back in, we can see that we got the word another, which is great. So now that we've covered yanking to a decent extent, we can cover its mirror functionality, pasting with P. Now P.
Okay, it's actually you have to yank. Then let's do that again. Try to copy this one. So where is our cursor? Okay. So escape means we disable. Okay. Capital Y. How can I yank? Okay, this is a yanking. Yank, copy a line. Or maybe we need to select it. Okay, in the visual, like that. And then Control, Shift Y. And then we can switch window and then paste. That's how to do it. Okay, we remove this. So this is a probe task. Okay, we rename this into a task. So task. Okay, then a probe would have list of tasks. Okay, it's an array of task. Where is my pointer? Where is my pointer? This keyboard is very difficult to read. I need a keyboard that actually highlights. Okay, no problem. Task. So we have tasks. Okay, and yeah, from there, we can create an implementation of task type HTTP task. It's a structure, and it will how to copy like that, and then okay. What I did wrong? Yeah, I did something wrong. Actually, this is actually an implementation method of task. So function, let's put the receiver is task. Okay. What the hell? Okay. That's our implementation. Okay. Yeah, to execute, you need to provide the context. I know this stream, my coding is clunky, so clunky because I just learned Vim and I insist to learn using coding using Vim, so please bear with me. Okay, we have probe names. So we have a probe with a name, and then tasks, list of tasks. We have a tasks, and then each of the tasks will have schedule. So schedule is not based on probes, but task. So this schedule is actually should be put in the task part. So there you go. Let's put some other interface method to question whether a task can run or not. Yeah, so we have to implement the can run based on the schedule that we have. Let's create another implementation. Okay. I didn't mean to copy the entire line, but let's do that again. I need to learn this. God. Okay, we copy that, and then Shift Y P. It copied the entire line. How can I copy just that part? V. Get that? should I just put Y and P? Capital Y will copy the entire line. Just a normal Y, it will copy the selected text in the visual mode. Okay, so can run boolean. So we're going to need to get the current Unix timestamp in UTC. So time dot now, and then UTC, and then Unix. Okay, this is the current timestamp. Is that how we do that? Sorry. Yeah. So we have now, we get the time for now, and then how to get the UTC part. Time, okay, UTC, you get the time in UTC, and then we just simply call Unix. Unix return Unix time in the numbers of second elapsed since January UTC. So it's already UTC, so we don't need to hold on. This could be dangerous because if our current timestamp is not UTC, meaning that we can, when we call Unix, it's our time since UTC, but to our current time zone. So our time need to be in UTC first, then we call the Unix to make sure that it is the true UTC time. Okay. Or let's try to make a test of this. So let's open, edit, what is it? Probe test. Okay, so let's test UTC. Function test UTC testing. It's a testing T, and then let's put something like now. Now is a time.now, and then from there let's get the UTC in our current timestamp now. So local UTC is equals to now dot UTC. No, not local UTC, local Unix. I'm sorry. Okay, and then UTC local Unix is equals to now dot UTC, then Unix. Okay, if local Unix equals to UTC Unix, it's not equals, then T error with a message of okay Unix method always goes to Unix method depends on your local. Okay, go format. Okay, sorry, I need to write it first. Okay, undefined time. Okay, sorry. Okay. Okay, we have time now. Task invalid receiver. Yeah. I am very sorry. It's HTTP task. Syntax error unexpected in probes.go. Oh, it's an interface. You don't need this. Okay. Line 6. What? What is a mess? Line 21. Okay. Current declared but not used. Okay. Let's disable this for a moment. Ah, damn, I'm stuck. Probes go. Import not used time. Okay. I'm so spoiled with GOLANG. I know. Okay. Undefined time. What I do? So it is actually equals. So doesn't matter. You call UTC or just now.unix. Whether your location is on UTC or your location here, local in Indonesia, when you call Unix, you will get the same value which is in the UTC. Yeah. How we can see go test with verbose value? How? Okay. Vim go test verbose. How to verbose info in go test? Go test. Okay. Go test. So that's how you're going to do it. Go. Okay, with exclamation. But I don't see the log. I need to lock format print line, but cannot use -v or -count equals 1 argument. Just run it from the shell. Go test. So FMT actually produced something? Let's try it. Strange, I don't see it. It's not come out. How can I see it? Well, this is not make things easier. Let's try if it's an error coming out. Yeah, it failed. Okay. 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 So we know that Unix now.etc should be sufficient. we don't need to use UTC here, because Unix will always return the Unix timestamp in UTC. Then what we're going to do, let's iterate through the HTTP task, schedule. Okay. For we don't indexed, schedule time equals to range of t dot schedule. If schedule time equals to current t timestamp, return true. If it's not, return false. Expected or end of line. I see. Yeah. Okay. Hold on a moment. I need to see this. There is a okay. Let's continue. Okay, can run. So every second by second we check within our schedule if this execute can be called. I think we don't need this validate anymore. We can throw it. We just need to focus on the execute part. Okay. Make sure that closed. Control WD. Could not find definition. How to close a buffer. BD. Oh yeah. Okay, let's open job. How again can we open another window? Please bear with me, guys. I need to learn this. I have to force myself to learn this. Otherwise, I will never know how to use Vim. I have to make this as a habit. Okay. Edit file in new buffer. Okay. Split windows. Okay. Split is S. S is a split. Yeah. Okay. Quit windows. Q. Okay. Control W. Split. No. Let's close this first. Then Control W split. Okay. Control W W, and then edit. Oh, sorry. Control P. Job. Go. Okay, we open our job. Okay, let's copy this entire thing. Okay. Visual mode. Okay. Why? What I did, I copy everything, right? So Control W P. Yeah. Control W Q. Okay. So from our context, so we're going to call HTTP task execute. That execute is belong to HTTP task. HTTP task will have task name, obviously. It should know the probe, because this is the probe name and this is the task name. So we must be able to discover what is the probe name, what is the task name. We have a probe, we have a task. The task should have a name. Yeah, name is a string. And then if we save, sorry. Oh, if we save, it automatically do go FMT. Okay, that's good. That's good. Okay. Okay, task have a schedule, have an execute, and task we will know the name of the task from the HTTP task, and from there we need to know the probe name. So obviously, HTTP task need to have reference to the probe. It's a structure, right? So yeah, something like that. So when we execute, we need to know the probe name. This is the task name. And we need to know the type. The type need to be HTTP, right? So get the task type. So from the context dot get, the key would be something like probe dot some string parameters that we're going to put there, which is the probe name and then the task name, and then type. Okay. Okay, what is it? Go info. It will return an interface and an error. Oh shoot, what I did. Forgot to insert. Newbie kind of error. Mistake. Never use Vim. So we have type. Oh my god. Type interface error get. Yeah. If error is not nil, we copy this, because if there is an error, we just simply do that. Escape, visual mode, and then Y, and then P, P. Okay. HTTP. This is not how we're going to do that. To do this, because we're going to put a task error. FMT. Oh, we haven't put this information. Task dot probe dot name, right? Yeah. With task name. Okay, we put the same way. Probe, the probe name, we simply put on the probe level. Have error is true. This is task.probe name. What I did. Probe have error. Yeah, we simply put the error. Probes task have no name. Please set this. Should be something like that. Probe right t.probe.name t.name. then we return. Okay, this is how we're going to get the type. Okay. Types equals to type interface casted into string. Okay. If types equals to HTTP, then we execute the HTTP part. This is to execute a task. Yeah, this is to execute a task. Let's do this in more elegant way. So in the future, we don't have to change this anymore. So just switch. Types. Case. It's a string. Oh, HTTP, sorry. Or even better, if we put strings dot to upper okay, to upper, and then we put this as HTTP. Then we call t dot execute HTTP. So we put the we put the context still. Default. If there is a default, if there we don't know what is the type, v y p insert. There is an error. Probe task type not recognized. This is the type, which is types. Okay. Simply return. Okay. That is our function. So let's create the function to do the HTTP task. What is it? The function execute HTTP context, which is a monitor context. Missing comma in the argument list, line 37. Column 3. Line 37. Return. What the hell is this? Okay, try 41. 41. Expect an operand. Found case. Yeah, it's a switch. "46. Missing comma." What is actually happening? Go. Missing comma. 36. What comma did I miss? Ah! I'm so spoiled. I am very sorry, guys. So spoiled. Yeah. Let's remove this. Yeah, we will do this later. Okay, line 45. Missing comma. What comma did I miss? "45, column 34. Yes. Because I'm stupid. "454. Do we need this checking? I think we don't need, right? Not terminated string literal 134. Oh yeah. expect. Okay. Phew. Wow. Okay. When we call execute, it will try to look for the probe dot name of the probe dot name of the task dot type. So pretty much like this one. This is the name of the probe. This is the name of the task. This is the name of the probe. Yeah, this is the name of the probe. This is the name of the task. And then we get type. Okay, we have the interface to the type. And then we cast it into a string, make it uppercase, and then we evaluate whether it's actually equals to HTTP. If it's equals to HTTP, we call execute HTTP. So this is what we're going to call execute HTTP. We provide the same context. And then from there, we are looking for, we don't use count anymore. We need to look for the URL. Execute is execute task again. I need to remind me of that. Okay, one by one. Next, we're going to look for the request URL because this is an HTTP task, right? We don't need this monitor anymore. How many the count? Yeah, we need a variable for storing our URL. Just preparing. It's a string. So look from the context. Yeah, look from the context for string, something like this, right? Oy. Yeah. This should be the probe name. This should be the task name. Okay. We should use get if there is an error. Can I do this? Oh, it will not work. Undo. Because we have a line numbering there. What I did. Copy. Paste. Yeah. If the URL is not specified, then there is an error. The error is that probe task URL not specified. Okay. We need to specify this in the parameters, which is the t.probe.name, comma t.name. Okay. Yank. P. Just remove this extra brace. Okay. If it's specified, then we just put the URL to call is equals to the string URL dot casting to string. Okay, then we need to know the method. Yank P string method get spring probe request method. Task method not specified. And then we can put the string method equals to the URL method to call, method to use maybe. Oh yeah. If we're going to refactor using Vim, there is a big challenge, I think. How to do refactoring using Vim Go. something we need to live with. Let's look into it. Let's find out. Let's find out how to call refactoring using vimgo. Vimgo. Go rename. Let's try to find out. Can we go rename this thing? To? Wow. M context. Whoa, it works. Okay, that's how we do that. Let's try again. Go rename into okay. Wow, it really works. So that is how we can do rename. Wow, this is very good. I'm going to like it. I'm going to like this. Yes. Okay. Okay, let's put fetch the URL to call. Fetch the method to use. And then from here, what are we going to do? What is actually this code doing? This is to put the request header. Okay, this is where we create the request. So I guess we can remove this. Let's validate, I think, the method to call first. Okay, what is a valid HTTP valid code? Okay, valid code equals to array of string. Valid method is get, post, put, what is it, delete, head, what else? Get, post, put, delete. Okay, HTTP method is only get, post, put. delete, and head. Let's look. Patch. Post, get, put, patch, delete. Head. Where is head? I thought there is a head. Connect, options, trace, patch. Okay, get, head, see? Head, put, delete. We need connect, options, trace, connect, options. What else? Trace, patch, right? Get, post, put, delete, head, connect, option, trace, patch. Okay. Now we're going to validate if this method call contained within the array. For method valid equals to false. So for m in range of valid code, if strings to lower of method to call equals to m, means that this method valid is true. If method not is method valid, it's not valid, we will return this error. Yank p. Okay, have error true. Task method is not recognized. Let's display also the method which is not right. What is the method? Yeah. 145. Yeah. No problem. Okay, assuming the method is valid, we can create the request. the method to call should be strings to upper, method to call, and the URL will be URL to invoke. URL to call. Okay. If there is an error, okay. Ish. Okay. If there is an error, okay, we need to change this. Undo. Oh, sorry. Paste that. Okay, probe have error. Yes, task. The error task test. Task this got this. So the first is that probe with a probe name and task name. This should be all, comma, got error. So if there is no error, means the request object is created. Then we need to parse through the header. Visual mode. So we iterate through all the context, looking for something like probe probe dot, this is the probe name, dot, this is the task name, dot HTTP request header. Okay, probe request. Okay, we get the type. Okay. Okay, since we get the type, so this should be a type first. Okay. Yeah. HTTP. This is so the key should be more distinguishable that this task is actually what kind of task we need to invoke. Okay. So we're going to iterate through the key. If the contacts have probe and then probe name, task, HTTP request header. Okay. So let's create a prefix first. Key prefix. Key prefix is equals to yank equals to, okay, this is not a call index. This should be the probe name. This is the name of the task. Okay. So if has prefix off, okay, then we need to find the header key. Okay, so it should be starting from the length of key prefix, and then we split the values with comma, and then we put request header with header values. Yeah. Next, validate the header. Okay, we validate the header. If the header is valid, then we create a new request. And then we iterate through the header. Okay. And then we look for the body. Okay, what we're going to do? Okay. We look for the probe. What? Undo. Okay. Insert probe dot. There's probe name, the task name. HTTP request body. Okay, if it's contained, okay, we need to put the probe name, t dot probe name, comma t dot name. Okay, don't need this. We don't need base64 type of coding. We just assume that the body is already in text. We don't need this encoding anymore. So we just fetch body interface error equals to context get okay. Oh, sorry. Yank. Learning, guys. Learning using Vim. Okay, we get the body. If there is an error, there should not be an error, right? Because we already checked from the context that it should contain, so there should be no error. So let's ignore this error because we already checked. Yeah. So the text, the body text should be body interface dot string, and then the length of the body is more than 0, so we put inside the request new reader so we need a byte, so let's cast it into a byte array. Let's cast this into a byte array. Okay, once done, we create the client. Vmode. Okay, create the client. And then we check if the request should validate the SSL. Copy that. Okay. So what are we looking is that if the probe name, task name, HTTP request insecure skip verify, which is this is the T probe name, this is the T.probe. Okay. We don't need any more call index. Yeah. Then we create the transport. The transport should use insecure skip verify. Then here we calculate the duration. V. Okay. Start time now. We're going to start the timer to get the response time. Okay. Client do, meaning that we're going to call the request and then look for calculate the duration, and then we put the duration information back into the context. So we put here context dot probe name, task name. Wow, this should be string because the parameter we provide is string. Okay, is that all? Yeah. Okay. The error also not right. Probe. Yeah. Right? Yep. Let's remove this. We don't need call index. We need the probe name. What is it? T dot probe name. Right. T dot probe name. And then we make sure that the body is always closed. And then we put the response code. This This is the probe name. This is the task name. HTTP response code. Okay. Can we just put the response status code? Okay. And then the header. So we iterate through the header, all header. So the probe, this is the probe name. This is the task name. HTTP response header, this is the response. So we should provide with the probe name, T, probe name. This is the task name. And this is the header. Key. Then we put in the header with comma delimiter. And then we look into the body. Body byte, read all the body, and simply put, let's remove this, put back all the body into the context. So the context, the key would be probe dot, this is the name of the probe, this is the name of the task. HTTP response body is response body, is a string. So yeah, simple casting to string. But before that, when we read the body, we need to make sure that there is no error. If error is not nil, so we just copy the error. Okay. Sorry. Yank it. There. Paste. So probe have error. The error is string. Okay. Yeah. And then what we're going to do with this number of calls, we move to the next call. Should we? No. No, we don't need this. Yeah, because we already done this. Yeah, this is only a redo from the old code. We remove all this. Okay. If the request have body, we put the body into request. This is funny. If the context request have body, we put the body into the request. Okay. and then we create the client. And then create a transport to ignore TLS or SSL certificate validity. If we are required to skip it, this check. Okay, and then start timer to measure request response time. Okay, make the HTTP call and then calculate the duration. Okay. If there's a client error, okay, close the body stream if there's no error. When we are done. Here, okay, record the response code into the context. Record all response header into context. And get the body if any body byte, if length of the body byte is more than 0 byte. Okay. Okay. Okay, let's escape, split, and I need to open this. Edit, probes, test, go. Okay, so let's test this logic. So function test execute HTTP. So we need to provide testing. So what are we going to do? Let's create our own context, shall we? How to create the context? think it's already inside the job test. New monitor context. Yeah. Okay. What I do? What I did. Okay. So don't mean that. I need to copy this. Yank. Okay. We need to do probe 4. P4. How we can close this? How we can close this buffer without editing, without applying? Okay. How we can close this buffer? Buffer quit. Not an editor comment. Buffer delete. Okay. Sorry. Control W, split. Okay, this is buff probes. Sorry, Control WW. Okay. Buffer 4. Okay. Now I forgot. Context. New. What context? Like that. Okay. And we put values. Okay. We put values into the context to execute it. First, we need to specify the probe types. Okay. I think a probe should also can be executed. Oh, okay. So let's not test first. Control WW, Control WQQ. Okay. Oh, I need to write it first. Okay. Right. Control Y. Okay. Let's make a probe to become an interface. So let's click the implementation type, default probe structure. Okay. Let's yank this, put there. Let's change this into an interface, and then probe should, we can call it execute. Oh, task have schedule, not probe, right? Yeah. This is a probe. Oh, this is okay. This is a probe, then this is a schedule. So probe should have schedule. So not the task. Oh shit, where is it? Where is it? Okay. The probe name is GoFood dashboard. And there is a schedule. So actually the probe who have schedule. So the implementation of can run should be by probe. So we don't need this. Should we go up there? And H. Yeah. Yeah. So probe have schedule, not the task. So we need to change this. I think move it. Can we like that? And put it here. Ah, yeah, it works. So this is actually the default probe. So default probe has can run. So it's checking the default probe for schedule. Default probe schedule. So the schedule we move up. We move this into the probe. Okay, probe have schedule and task. Okay, if this probe can execute, can run based on the schedule, then it's written true. If it's not in the schedule, so it's written false. Okay. Then task can only have execute. The implementation is HTTP task. Oh. Execute execute probe. This one is execute task. So it's going to be execute task, this one. And we have to create an execute probe. Function, default probe, DP. Why DF? DP. Execute probe context monitor context. Okay. Then we're going to look for this information, the task and the schedule. Okay, when we call execute, actually the context should be already been formed. So before we implement this, let's create the function to create new default probe. New probe, provide us with a context. We return you with a probe. Or an error if there is something wrong. If there is an error, okay. So what we're going to do, we're going to look into the context for some informations. Okay, like list of probes. So let's copy this. We don't need that. We just copy, yank the entire line. Okay. Well, why is it only get? It could be an error because get should coming from the context. Yeah. Context get. What we are looking? Probe names. Since this is an expression, I think this should be like that. And this is also an expression. So an expression could be an array. That's problem because we haven't done the compilation. We haven't done the compilation, the evaluation of array. Oh my god. We need to create an array literal. I'm going to do this off screen because our session is already taking too long. I'm not going to waste your time. But this is a programming activity that we are doing. Programming activity could take lots of time, could take hours and hours. I don't want to stream hours and hours unless you tell me whether I should do that. And you have to keep following me coding. And coding is not things that people going to enjoy looking some other person doing the coding, and you just look and look and look without any interaction, and then you just fall asleep. You won't stand a chance. So I just that's why last time I always try to keep like 1 hour 40 minutes maximum. So this is already what, 1 o'clock to 3.5. So it's already 2.5 hours. So let's stop the stream right here. I'm going to stop. Thank you. If you able to follow this stream, watch it from the first minute to the last 2 hour and a half. Thank you very much. Please subscribe to my channel, or at least leave a like. Keep visit this channel to see scheduled live stream, because before I do the live stream I always schedule it, and you can put in your schedule to come and see my stream. Okay then, thank you very much.